Hello 8th graders, today we're starting on part 3, which is all about Newton's second law, which is also the title of this unit. And the reason it took us to get to the title lesson by part 3 is because we needed to build some background knowledge about what acceleration is and how to do free body diagrams before we can put those things together into what is Newton's second law. We needed those skills first. Before you start this lesson, make sure that you have finished the warm-up in Google Classroom and sign up for office hours if you need any help so far. Also, like always, you're going to need your notebook with the notes and practice side. Today you're going to be able to explain the relationship between all of the variables that cause acceleration. So we've already got one acceleration equation where you found out that it was the change in velocity over time. That's one way to measure or calculate acceleration. Newton's second law is the other way to calculate acceleration. So that's going to be your second objective, to be able to describe that law in words. And then the third one is putting it all together. You're going to be able to use Newton's second law in a free body diagram, that's the picture with the arrows, in order to figure out missing variables. So like in order to figure out how heavy something is or how fast it was going, things like that. Before we get started, I want you to work on understanding the concept of Newton's second law. And in order to see that concept, I'm going to ask you to go to this mini lab. So it's linked in Google Classroom. It's called the Push It Concept Builder. As you go through, make sure that you're following the directions on the page and typing in and filling in the table as you go. Pause this video and come back when you have finished the mini lab. If you are still watching, you have finished the Push It mini lab, and hopefully you have seen something that you kind of probably maybe already intuitively knew. So the idea is that if you have something really heavy and you want it to accelerate, you have to push really, really hard. And if you have something really light, you don't have to push as hard to make it accelerate. But that's what Newton's second law is all about, is calculating those three things. How hard do you have to push? For how big of a mass? For how much do you want it to accelerate? So it's those three things put together that make Newton's second law. So let's get that down into your notebook. So on the left side of your notebook for your notes today, I need you to copy down what I have on my screen. So we're going to start off with this idea of a balanced equation. So remembering back to our free body diagram lesson, if you have an object that has balanced forces, where everything cancels out in the up-down and the left-right direction, Newton said that those things will not accelerate. That's his first law. So this is an object that will keep doing what it was doing. If it was at rest and it has balanced forces, it's going to stay at rest. If the object was already in motion and it had all these balanced forces, it'll stay in motion. Object in motion, object at rest, stays doing what they're doing, if it's balanced. So then the other side of that is the unbalanced equation. So Newton said if you have some object that has experienced unbalanced forces, like this one on the screen, then that is a thing that is going to accelerate. And that's what his second law is all about, is figuring out how much will it accelerate. So he said that this is an object that will accelerate. If it was at rest or moving to the right, it'll keep going and speed up to the right. And if it was going to the left, but it experienced these unbalanced forces to the right, that's an object that would start to slow down. Remember, slowing down is a form of acceleration too, but it's going to change what it's doing because it's unbalanced. So the one on the left is all about Newton's first law. Objects at rest staying at rest, objects in motion staying in motion. And the one on the right is all about Newton's second law. What happens when they don't stay doing what they're doing? Pause this video if you need to add these things to your notes. We need an equation for this, so still on your note side, make sure that you have this equation down because you're going to need it a bunch. And it's a pretty simple equation. There's not a lot of pieces to it. So it's net force equals mass times acceleration, and it has another handy little triangle to help us to rearrange things in case we need to solve for another variable. As a reminder, if you need to solve for mass, you cover the thing you're solving for, you would cover mass, and you can see that it's force divided by acceleration. Or if you're solving for acceleration, cover A, and it's force divided by mass. So you can solve for all three parts of this equation, and we're going to need to in this lesson. Let's talk about units. So for mass, we're staying with kilograms. And we've already done acceleration. That unit is meters per second per second. Now, you might be thinking, oh no, like when we did momentum, this is going to have one of those crazy units, like a kilogram meter per second per second. That just sounds nuts. And technically, that would be a unit for force. But fortunately, physicists said, you know what, that's a little too crazy. That's over the line. So let's give force its own unit. And they actually named it after Newton. So net force is in newtons, named after the guy who pretty much defined all this stuff. Remember, net force is when you add and subtract the arrows, and it's what's left over. So if you have 5 newtons going this way and 10 newtons going that way, 5 of each of those cancel out, and you're left over with 5 going that way. So that's what's going to go into this equation. We're going to do some practice problems. So over on your note side, there are going to be 4 different types of problems, and I want you to have these 4 examples in your notes so that when you do practice on your own, you can go back and look at these specific problems to help you get unstuck in case you get stuck. So the first type is one where you just have to find the force using Newton's second law equation. So here's the situation. We've got this guy pushing a big boulder, it looks like, and the boulder is 400 kilograms, and he is going to make it accelerate at 2 meters per second per second. And we're supposed to figure out, well, how hard does he have to push in order to make that happen? In physics, you should always, always, always start with the equation. Now we've added another one, and we're up to a few equations in physics class. So it starts to become pretty important to start with that equation, especially when I'm looking at your work, and if there's a mistake, I can help you to figure out what happened if you've shown me what equation you're using. So we're going to start with our equation, F net equals ma, and then start plugging in the things that we know. So they gave us a mass, and they gave us an acceleration. We can plug in those 2 things. We're still trying to solve for force, so I'm going to leave that as F. Now we just have to go and plug these things into a calculator or some mental math. So 400 times 2. The force that he has to push with is 800 newtons to the left. Remember, force has a direction. If he wants it to go accelerate that way, it's going to have to require a force going that way. Pause the video and add this to your notes if you haven't already. The second type of problem is one where we would have to either solve for acceleration or mass. And this is where the triangle might come in handy. I'm going to show you using just algebra, using the original equation, but you could also start by rearranging things using the triangle also. It'll work either way. So we've got the same guy, the same boulder, 400 kilograms, and we're going to say this time, let's say that he was able to push with 200 newtons, and we want to figure out how much it's going to accelerate. So we're solving for A this time, but we're still going to start with our equation. F net equals ma. Plugging in the things that we know that he's going to push with 200 newtons, and that the mass of the boulder is 400 kilograms. Now we just have to do a little algebra, and on the right-hand side, since we have 400 kilograms times A, in order to get A by itself, we have to undo the multiplication. So that means we have to divide both sides by 400. Got to do it on both sides in algebra in order to keep it an equation. That'll get rid of our 400, and on the left-hand side, we'll end up with a half, 200 divided by 400. So we'll have 0.5 meters per second for our acceleration. And I've noticed a typo. Since I've noticed a typo, see if you can notice my typo before I tell you what it is. I'm missing my direction. Accelerations have a direction. So since the man is pushing on the boulder with a force to the left, I should have also had an arrow or the word left with my answer. 0.5 meters per second to the left. Hopefully you've added that to your notes already. Pause this video if you still need to add this before going on to the third type. So here's the third type of question. This is one where we need to find the net force first. It's not just one number. We have to find the pieces put together. So here's the situation. We've got this box that has a mass of 5 kilograms, and it's got a force of 5 newtons on one side and a force of 3 newtons on the other side. And our job is to figure out how much is this thing going to accelerate. Well, we always start with the equation, F net equals ma. And in this equation, they're giving us some of the forces and the mass, but we don't know A. In order to find the net force, remember, you have to add and subtract the forces. So since we have 5 going one way and 3 going the other way, they're opposing each other, we have to do some subtraction, because some of that is going to cancel out. So I always start with the bigger number. So I'm going to start with the 5 newtons and take away the 3 newtons, and I'm left with 2. Keep in mind, it's a good idea to have a picture there in your notes too, because then it'll remind me that it's 5 newtons to the right. We'll save that for the end. Hopefully I didn't make a typo again. So we're going to do combine our terms. We'll get 2 equals 5a, and just like in the last question, we have to undo the 5a by dividing by 5. So we're going to divide both sides by 5, and we're going to get an acceleration of 0.4 meters per second, and I left my typo again. We need to have 0.4 meters per second to the right, since the net force goes to the right. Pause this video if you need to still add this to your notes. For the last type of problem, this is the one that is the most complicated, especially if you're feeling a little uncomfortable with with algebra. So if you need to rewatch this section, that is totally perfect. That's why they're in videos. And make sure you're taking really good notes too, because you're going to see a problem like this for sure. So this one's complicated because there's a lot of parts. We've got the same guy as a few questions ago who's pushing a boulder. And we're being told that the boulder is 400 kilograms. This time, I guess he's been working out. Now he's pushing with 3,000 newtons. And the boulder is accelerating with 5 meters per second of acceleration. The most common mistake that I see students make on this is they're like, well, wait a second. You're telling me the mass and the acceleration and the force? What is there left to solve? I don't see what we're doing here. Well, if you were to plug in 3,000 newtons equals 400 times 5, force equals mass times acceleration, that wouldn't be an equation. It wouldn't be equal. So what must be happening here is there's some amount of friction that's pushing back against the man, and our job is to figure out, well, how much friction is pushing back against him. So in other words, if you have this big boulder and you push with 3,000 and it accelerates this much, how much must the friction have been pushing back against you if all that other stuff is true? Well, the good news is that we solve this the same steps that we've been using so far. Always start with your equation. F net equals ma. So our F net part is the part that's going to help us to solve. We know that he's pushing that way with 3,000 and that friction is kind of countering some of that force. We're going to have to do 3,000 minus however much that friction is. We'll just put in an x. And that's going to be equal to the mass times the acceleration. So now we have our equation set up and it's time to solve. The first thing that we have to do is combine our terms. So we have 405 on the right side, so we'll combine those. So we have 3,000 minus x equals 2,000. And now we have to get rid of this 3,000. So since the 3,000 minus x is an addition-subtraction thing, we have to get rid of the 3,000 by subtracting it. So we're going to subtract 3,000 from each side, and this is where your signs get really, really important. So we're going to subtract 3,000, which is going to take away the 3,000 from the left side, but we'll still have a minus x. So the left side will be minus x. On the right side, if we had 2,000 but we took away 3,000, we're going to have a negative 1,000. So we're ending up with negative x equals negative 1,000. Well, hopefully you've learned in algebra. If you haven't, you'll learn it here first. If you have a negative on each side, then basically it's saying negative 1x equals negative 1,000. Well, we can take away the negatives if we divide each side by a negative 1. So negative x divided by negative 1 equals x. Negative 1,000 divided by negative 1 equals 1,000. And basically those negatives cancel out since it's on both sides. Once you've canceled out those negatives, we are left with 1,000 newtons going to the right, since friction was pushing against the man, as our final answer. Pause this video if you still need to add any of this to your notes side. Now it is your turn to get some practice in. So over on your right side of your notebook, I need you to do these 4 problems. I do not need you to rewrite the whole question, but what I should see on your notebook is at least a sketch of the problem. So like you can use a box and some arrows, so I should see a free body diagram. I should see things labeled with their units, and of course, I should see your equation started with the formula, F net equals ma, and then plugging in your stuff in order to find your final answer. When you are ready to check your answers, there is a PDF attached in Google Classroom that has all of the answers. Make sure that you check when you're done. For some additional practice, I next need you to go to the link that's on your screen. There's also a link in Google Classroom in order to get to this site. I want you to see what it looks like. When you get to the site, you'll see this, and there will be a little tiny window. I've expanded mine a little bit. But if you click on the top left where these 2 arrows are, it'll expand to take up the whole screen. For this practice, I need you to choose 2. You can either do the apprentice questions and the master questions, or if you're feeling confident, do the master questions and the wizard questions. Whichever ones you do, though, here's how it works. It's going to give you 4 pictures. And you need to be really careful about the directions, because what you're doing is you're ranking the 4 questions from least to most. And sometimes it'll ask you to rank the forces from least to most. And sometimes it'll ask you to rank whatever the acceleration of the object would be from least to most. So for example, right now on my screen, it's just asking about the forces. So I have a scratch piece of paper next to me, which I super recommend. You can use your notebook in order to help me remember which one had how much. So for example, the top left picture, because I'm just caring about forces, has a net force of 8 to the left. And in this program, anything to the left is negative. So this one would be a -8. And it wants me to rank from most negative to most positive. So the top left has a -8. That's a pretty negative one. The next one down here has 6 to the left and 4 to the right. That's a -2. So far, that's the next most negative. Then the bottom right, if I cancel the 4 with some of the 6, I'm left with a +2 to the right. That's a positive direction. So that's the next biggest one. And then the biggest out of the 4 is a +8. So that's going to get the biggest rating. And when you check your answers, it'll tell you that you've either made some mistakes and tell you how to help it, or if you've done it well. So pause this video and do 2 levels before you come back. To close us out today, please take a moment to make sure that you've got all of the things attached to today's assignment. The first thing was the warm-up about acceleration questions. Then you need to make sure that you have your Push It mini lab attached to the assignment. And then, of course, a picture of your practice page. And what I'm looking for in your practice page is work shown. That means I need to see a diagram with the free body arrows on it, and I need to see your equation with your work shown. If you don't have those things, please take a moment and go back and clean it up before you turn this assignment in. Ready, go.